The process of mass production of steel bars, stages, and technologies. Steel bars are a key material in construction, engineering, and manufacturing. They are used to reinforce concrete, create metal structures, machine parts, and tools. The mass production of such rods is a complex but highly organized process based on metallurgy and modern technologies. Let's consider it in stages. Preparation of raw materials. Three components serve as the basis for steel production. Iron ore, hematite, magnetite, is a source of iron. Coke is purified coal, which acts as a fuel and reducing agent, removes oxygen from the ore. Limestone is a flux that binds impurities, sulfur, phosphorus, into slag. These components are mixed in certain proportions to form a charge. It is loaded into a blast furnace for smelting cast iron, an intermediate product. Steel smelting cast iron contains about 4% carbon and impurities that make it brittle. To obtain steel, it is processed in a converter or electric arc furnace. 1. Molten cast iron is poured into the converter and oxygen is purged. Oxygen burns off excess carbon, reducing its content to 0.02 to 2.1%. 2. Alloying elements, chromium, vanadium, nickel, are added to give the steel the desired properties: strength, corrosion resistance, flexibility. 3. The temperature reaches 1600 to 1700 degrees Celsius. The finished steel is poured into a bucket for further processing. Continuous casting of workpieces, casts. The molten steel is turned into blanks using a continuous casting machine, CML. 1. The liquid metal enters the mold, a water-cooled copper mold. The steel hardens quickly from the outside, but remains liquid inside. 2. The workpiece is pulled by rollers through the secondary cooling zone, where its surface is treated with water. This forms a dense crystalline structure. Third slabs, thick slabs, or blooms, square blanks, are obtained at the output, which later become rods. Rolling the blanks are sent to a rolling mill, where they are turned into bars of the required diameter. 1. Heating. The workpieces are heated in furnaces to 1100 to 1200 degrees Celsius to make the steel ductile. 2. Rough rolling. The workpieces are passed through a series of rolls, which gradually reduce their thickness. For example, a bloom with a section of 200 by 200 millimeters turns into a rod with a diameter of 50 millimeters. 3. Finishing rolling. The final rolls give the bars a precise diameter, usually 6 to 40 millimeters, and shape, round, ribbed. The ribbed surface is created to improve adhesion to concrete. Such bars are called rebar. Cooling and processing. After rolling, the bars go through several stages. 1. Accelerated cooling. Hot rods are placed in cooling chambers where they are blown with air or water. This increases the strength by changing the structure of the steel, formation of martensite. Second correction, the bars are leveled on roller machines, eliminating deformations. Third cutting, automatic saws cut them into standard lengths, 6 to 12 meters. Quality control, each batch is checked according to strict standards. Mechanical tests measure tensile strength, yield strength, elongation. Chemical analysis, checking the composition of the alloy. Geometry, laser sensors monitor the diameter and edges. Flaw detection, ultrasound or X-ray reveals internal cracks. Defective bars are sent for remelting, packaging, and logistics. The finished bars are tied into bundles weighing 2 to 5 tons, labeled and sent to customers. To protect against corrosion, they are often coated with epoxy compounds or zinc, galvanized fittings. The production of steel bars is a chain of high-tech processes where precision and control play a key role. From the quality of the raw materials to the last stage of verification, everything is aimed at creating a material capable of withstanding enormous loads. It is thanks to mass production that steel remains the backbone of modern industry, combining the strength of metal with the engineering genius of man.